All right, today we are finally on the last lesson for our algebra skills unit, and we're solving yet another kind of inequality, and the last kind is the rational. So today we're going to solve rational inequalities. All right, in general, here's what we do. First, we set to 0, and we practiced this yesterday on the quadratic inequalities. We set those to 0. Then we're going to rewrite these into one fraction. All right, so we're going to form the least common denominator and then merge them into one. Then we're going to find the critical points, the critical values for the numerator and denominator, and then we have to do the testing intervals. So the critical values and the testing intervals is going to be similar to what we practiced yesterday with the quadratics. There is one piece, though, that I absolutely need to make sure that everybody understands. You do not cross multiply. All right, so that's really important. If I see you doing that for your first step, then I'm definitely going to mark you down for that. Just again, remember that the critical points, these are going to be the zeros. Of the numerator and denominator. So before we just had the numerator because we just had the quadratic, but now we're going to have a rational expression. So we'll have critical values in the numerator and the denominator. All right, let's go ahead and try one. Solve each rational inequality. Again, we're writing on the answers in interval notation. Okay, very first step, set the inequality to 0. So I've got x plus 1, x minus 1, minus x plus 2, x plus 1 is less than or equal to 0. Now, notice that the least common denominator here, okay, it's going to be x minus 1, x plus 1. So my left-handed side, that's going to be my new denominator, x minus 1, x plus 1. My first fraction is missing the x plus 1. So my first fraction here, when I multiply the two numerators together, I'm going to get x squared plus 2x plus 1. Right, and then notice that my second fraction is missing the x minus 1. And so that product is going to give me x squared plus x minus 2. And then simplifying my numerator, so don't lose your negative here. It's important that you don't lose that. So you've got to distribute that negative onto the product, right? So we multiplied that whole thing. So then my numerator is going to become x plus 3. And then my denominator is still x minus 1, x plus 1. All right, now for step 3. So we basically did steps 1 and 2 here. Okay, so now I'm going to work the critical values. So my critical values are the zeros of the numerator and the denominator. And so in this case, I've got -3, +1, and -1. Now I have to test the intervals. So my number line, I'm going to break it up. So my first one is at -3, and then I've got -1, and then I've got +1 here. I made that line way too long. Okay. So notice that you're going to have to do 4 intervals here because I've got all the numbers that are less than -3, the numbers in between -3 and -1, the numbers in between -1 and 1, and then all of the numbers bigger than 1. So I'm going to have to test 4 intervals total. When I do my testing, I'm substituting the value into this inequality here. Okay, so my rational inequality. And again, I'm not concerned about what the explicit value is. I just care about if the sign is positive or negative, because then that will indicate if it's a solution or not. All right, the first number I'm going to test then is -4. So I'm substituting -4 into the inequality. So I would end up with a negative in the numerator position. And then in the denominator position, notice I would get a negative times a negative. Well, a negative divided by a positive is negative, so that is less than or equal to 0. So that means that this is a solution region. This is a true statement. All right, next one, I'm going to choose -2. So notice, again, this time I would get a positive in the numerator, and then I would get a negative times a negative. Well, is a positive divided by a positive less than or equal to 0? And of course that's false. So that means that this interval is not going to give us any solutions. Okay, moving on to the next one, I'm going to choose 0. So notice that I would get a positive divided by a negative times a positive. So is a positive divided by a negative less than or equal to 0? And that's true. So that means, again, this is a solution region. And then my next one, I'm going to, in my mind, use +2. So then I would get a positive divided by positive. Is that less than or equal to 0? Is a positive divided by a positive less than or equal to 0? And that's false. And so this region is a fail. So that means my 2 regions that work then are any of the numbers that are smaller than -3, and then any numbers in between negative and +1. Now, how do you write out your final answer? Well, because my inequality symbol is less than or equal to, I'm going to include zeros of the numerator. But you always exclude, zeros of the denominator. And that's because if you included the zeros of the denominator, your function would be undefined every time you're inequality. And so those would all be failures then. All right, so -3 then was the 0 of the numerator here. So I want a hard bracket on -3. So -infinity to -3 with the hard bracket. And then positive and -1 were the zeros of the denominator. So those I want soft. And then that would be your final answer here. Again, you know, we're going to be looking for all of these steps when you do your test over this and when we look over your homework too. So it is a lot of writing. That's why we're not giving you a ton of problems with these, you know, because each one has so many steps on it. All right, let's go ahead and look at number 2. All right, so number 2, I've got x plus 12 over x plus 2 is greater than or equal to 3. All right, so the first few steps here, so again, I'm going to set it to 0. All Right, now notice that the LCD, of course, is just x plus 2. So my 3 is missing that quantity, so I need x plus 2 over itself here. So then I'm going to have x plus 12 minus 3x minus 6 is greater than or equal to 0. So then my numerator is 6 minus 2x over x plus 2, and then that's greater than or equal to 0. All right, now I'm ready to work my critical values. So my critical values here are my critical points. Well, the 0 of the numerator, notice, would be x is equal to 3, and then the 0 of the denominator is negative 2. So again, how did I get the 3? Just in my mind, I did 6 minus 2x is equal to 0, and so 2x is equal to 6, and x is equal to 3. All right, so now I'm going to break up my number line. This one's easier because I've only got 2 critical values. So 2 critical values, I have 3 points or 3 intervals that I have to check. When I do my checking, I'm using my inequality right here, and I'm substituting the numbers into that. Okay, so my first one, in my mind, I'm going to just choose negative 3. So then notice I'm going to get a positive over a negative. Is that greater than or equal to 0? And the answer is no, that's false. That would come out to be a negative number. There's no way that a negative number is greater than 0. Okay, now in between I'm going to choose 0. So notice that I'm going to get a positive over a positive. Is that greater than or equal to 0? And that's true. So that means that this is a solution interval from negative 2 to 3. And then to the right of 3, I'm going to choose 4. So notice I would get a negative over a positive. Is that greater than or equal to 0? Is a negative greater than or equal to 0? And that's false too. All right. Now again, notice that your inequality sign is greater than or equal to. So I want to include the 0 of the numerator, which is 3. And I want to exclude the 0 of the denominator, which is the negative 2. So my final answer here is negative 2 to 3. And again, soft on negative 2 and a hard bracket on 3. All right, number 3. So I have 4 over x plus 5 minus 1 over 2x plus 3 is greater than 0. Okay, notice that my least common denominator here is going to be x plus 5 times 2x plus 3. All right, my first fraction is missing the 2x plus 3, so I need to multiply the numerator and denominator by that quantity. So notice that you would get 8x plus 12. And then my second fraction is missing the x plus 5. So I would need to multiply x plus 5, x plus 5. And then when I distribute my negative and collect the like terms, notice that you would have 7x plus 7, and then that's over your denominator, x plus 5 and 2x plus 3. All right, now for my critical values. So notice that the critical value for the numerator is going to be negative 1, and then for the denominator it's going to be negative 5 and negative 1.5. Okay, negative 5, negative 1.5, there we go, and then negative 1. All right, when I'm substituting my values in, I'm going back here to my inequality. And again, I'm just looking to see if the answer comes out as a positive or negative, because that tells me if that is going to be a solution interval then or not. All right, so my first one, I'm just going to choose in my mind -6. So notice that you would get a negative over a negative times a negative. Well, is a negative over a positive greater than 0? And the answer is no, so this is false. Right, in between -1.5 and -5, maybe I'll do -4. So notice that I would get a negative divided by a positive times a negative. Well, is that going to be greater than 0? And the answer is yes. A negative divided by a negative is positive. So that's going to be a true. So this is going to be a solution region then. Between -1 and negative. All right, this next interval is a little bit harder, -1.5 to -1. So in my mind, I'm using -5/4, -1.25. So again, you know, when I'm substituting this, I'm doing 7 times -5/4 plus 7. And then in the denominator here, I've got -5/4 plus 5 times 2 times -5/4 plus 3. All right, so notice that my numerator is going to turn out to be negative. And then my denominator is going to be a positive and a positive. So is a negative over a positive greater than 0? And that's no. So again, this is a false. Right, and then my last interval, so anything bigger than -1, so I'm going to choose 0. All right, so this is an easy one. So I get a positive over a positive positive. Is that greater than 0? And yes, that's true. All right, now, because this is greater than, notice that it's not inclusive. We don't include the zeros of the numerator or the denominator at this time. Right, so you've got to really pay attention to, you know, the inequality symbol, because that's allowing you to decide if you should use a hard or soft bracket on any one of those critical values. So this one is all soft, so I need a soft then from -5 to -1.5, and then a soft on -1. So my final answer here then is -5 to -1.5, again soft on both, in union with -1 to infinity. All right, that's going to be the final answer. Okay, I think that should do it for you. So good luck with your homework assignment. This should be the last page in your packet, and you're solving your rational inequalities. Again, make sure that you write out your answers in interval notation.